Okay, 3.6b, chain rule. Let's see, example 1, find g prime of t if g of t is equal to -7 over 2t minus 3 quantity squared. Okay, so not everything is a quotient rule. I would like to remind you to please, sometimes you do just have to rewrite stuff. For instance, in this problem, go ahead and rewrite this function using negative exponents. Okay, so if you do that, you won't have to do the quotient rule, and you'll just do power rule. So if I rewrite this, I get -7, and then the bottom part is to the second power, but to bring it up to the top, all I have to do is make that exponent negative. Alright, so that's what I'm going to derive. It is a composite function. This is going to need or require a chain rule. So the stuff in here, that's the inside function. So I'm doing the derivative of the outside times the derivative of the inside. So now I rewrite this again. And this time it's going to be -7u to the -2 power. And let me go ahead and write my u stuff. So u is the inside function, 2t minus 3. And then du would be the derivative of that, which is 2. So when I do my derivative, g prime of t, I'm going to derive this function here, the outer function first. So let's see, the -2 times the -7, that's +14 u, and then subtract an exponent. Now this is my derivative of the outside function. Because this is a chain rule, I have to make sure that I multiply by the derivative of the inside function. And that is basically my derivative. It's just that now I have to make sure that I plug in u and plug in du because they're not real. It's just a means to an end. It's the way that I'm trying to figure this out. But it's not really a real function. So u is 2t minus 3 to the -3rd power. And then du was 2. And all I ask is that you please, when you have coefficients like that, the 14 and the 2, go ahead and multiply them. So 28, and then 2t minus 3 cubed. And that's my derivative, and I'm done. All right, example 2 is using the chain rule with the quotient rule. So the last notes involved product rule. This is going to involve quotient rule. Okay, so this is obviously a quotient rule because there's something being divided by something else. But of course, it has a chain rule. This in here, that's what makes it a chain rule. So that'll be my u. But since I know I'm going to do a quotient rule, well, first of all, let me refresh you. Quotient rule, right, is v times u prime minus u times v prime. So low derivative of the high minus the high times the derivative of the low divided by low times low, so v squared. Now we're used to using u's and v's, so what I want to do is I want to just go ahead and call this w so that we can keep our u's and v's separate. So I'm going to call this w. Okay, so what I have is w squared and then x cubed plus 3. So u is the top function, which is w squared. Okay, but remember w is not really w, it's really 3x minus 1. So eventually, when I do use u, I'm going to have to use 3x minus 1. All right, u prime, the derivative of w squared. So let's see, it's 2w, but because it's a chain rule, times dw. So maybe I should actually go ahead and declare what w is. So w was the inside function, 3x minus 1. So dw is going to be the derivative of that, which is 3. And then that just leaves v. I haven't done v yet, right? So I'm just going to scroll down a little and fit my v in here. Okay. So v is the bottom function. x cubed plus 3. And then the derivative of v is 3x squared. So I have my pieces that I would normally use for the low d high minus high d low over low times low. One of them required a little extra work using the chain rule. Okay, I used the chain rule. Let me go ahead and figure out what u prime actually looks like. So it's 2 times w. But w was, or is, 3x minus 1. And then times dw, which is 3. So basically, 6 times 3x minus 1. So if you don't mind, I'm just going to remove that 3, remove the 2, and I'm just going to put a nice big fat 6. Okay, so just like before, I'm going to use my u, right? I'm going to use my u prime. I'm going to use my v, and I'm going to use my v prime. And those are the pieces for doing my low d high minus high d low over low times low, right? So dy dx, dy dx is equal to v times u prime minus u times v prime. And there you go. I'll be honest, I wouldn't simplify this just because it's a little yucky. I would rewrite it a little bit. For example, the 6, let's bring that baby up to the front. And then everything else can just stay how it is. Because it's not going to look prettier, it's just going to look uglier. And I'm okay with that for right now. And then I put the 3x squared up front. But that's my derivative. Alright, b. Here I have y equals sine x divided by 1 plus cosine x to the the second degree squared, so second power. So this is obviously going to be quotient rule because I have something being divided by something, but those somethings are squared. So it's also a chain rule. I'm going to rewrite this as w squared. Okay, I already know that I'm going to need u and v for the quotient rule, so I just want to use w. So w is sine of x over 1 plus cosine x. Okay, well I need dw. dw is going to take a little bit more work. dw is going to be u divided by v. So this will be u, and this will be v, right? So the derivative of that, okay, so that's v, so 1 plus cosine x, times u prime, so the derivative of u, which is cosine x, minus u, which is sine x, times v prime, which is the derivative of the bottom. I derive the bottom, the 1 goes away, and the cosine x becomes negative sine x. And then all of this over v squared. So 1 plus cosine x squared. So there's my derivative. I should simplify that. So I will. Let's see. 1 plus cosine x times cosine. So I'm going to go ahead and just multiply. So I have cosine x plus cosine x, but it's squared. And then minus sine x times negative sine x. Okay, so the negatives become positive, and then the sine x's are squared. And then this is all above 1 plus cosine x squared. Alright, hopefully your spidey sense is going off and you're like, ew, looky what I found. Right here, I'm just going to trace over it. These two beautiful darlings here went together like that. They're a trig identity. They're one of the Pythagorean identities. Cosine squared x plus sine squared x equals 1. So what I have now is cosine x plus 1, or 1 plus cosine x. Why did she write the 1 first? I wonder. Let's see. 1 plus cosine x squared. Oh, looky. I got one on top and two of them on the bottom. So if I simplify, the one on top cancels out one of the ones on the bottom. So I have one left over on top. And on the bottom, I just simply have 1 plus cosine x. There is my dw. All of that work for dw. But all of this work was necessary. So now I have my w, I have my dw. And I can go ahead and just derive the very simple function that we have up there in the purple, the w squared. Okay, so let's see. Y prime is equal to, now my function is w squared, so if I derive that, I get 2w dw. And I already know what w is, right? I have w already. It's right here. And we did all the work to find dw, which is right there. So I get 2 times sine x over 1 plus cosine x, and then times dw, which is 1 over 1 plus cosine x. This could be simplified just a tad bit. 2 times sine x times 1 is just 2 sine x. But then the denominators, I have 1 plus cosine x times 1 plus cosine x. So that's 1 plus cosine x squared. And there's my answer. It's really not that bad, because we did all the other work already, right? All right, example 3, find the slope of the line tangent to the curve y equals sine theta to the 5th power at the point where theta is pi over 3. So basically what we're doing is we're finding the slope of the tangent line by finding the slope of the curve. So the tangent line and the function y have the same slope at theta equals pi over 3. So remember, in this class, slope is the derivative. So in order to find the slope, I'm going to derive. Okay? Alright, so derive. Now, this right here is a chain rule. I'm going to call it, let me write it over somewhere else. Okay, so I'm going to call this, it's sine of theta to the 5th power. And that's what makes it a chain rule, because I have an inside function and an outer function. So this is u to the 5th power. So when I derive, okay, y prime is, all right, what is the derivative of u to the 5th? So 5u to the 4th power, but because it's a chain rule, times du. So I need u and I need du. All right, so u, I'm going to write it right here, is the sine theta part. And du would be the derivative of that, which is cosine theta. So I can go ahead and finish off my derivative. It's 5 times sine theta to the 4th power times cosine theta. Now they want to know what the slope is at a certain point. So this is not just here for decoration. I'm going to have to plug that in. Okay, so I have 5 times sine of pi over 3 to the 4th power times cosine of pi over 3. Now this is not when we jump on our calculators. You need to know how to answer this without a calculator. Cannot stress enough how important it is that you memorize how to do the unit circle. At least for the most important angles. Okay, so I'm going to draw a little unit circle. All right, so there's my little unit circle. This is pi over 6, which is 30 degrees. This is pi over 4, which is 45. And the one we're dealing with in this problem is pi over 3, which is 60 degrees. So here at 60 degrees, the coordinates are, well, everything's being divided by 2. And then if we started here at the top for the x value, it's a 1. I would have counted down 1, 2, 3, right? So 1, 2, 3. And then for the y value, I would have started counting here again. 1, 2 for 45 degrees, and 3 for 60 degrees. So this is the square root of 3. Okay, so I have my values. Please remember the x is the cosine and the y is the sine. Okay, so I have my numbers. No calculator necessary. So 5 times, let's see, the sine at pi over 3 is the square root of 3 over 2. And that's going to be to the 4th power. And then cosine at pi over 3 is 1/2. So then this is just algebra, okay? Which is not when you want to make a mess, or yeah, make a mess or make a mistake. Please, no messing up on the algebra. Let me make myself. All right, so 5 times the square root of 3 to the 4th power, and then over 2 to the 4th power, and times 1/2. So let's see, square root of 3 to the 4th power, right? So that's square root of 3 times the square root of 3 times the square root of 3 times the square root of 3. So these become 3, and these become 3, so 3 times 3 is 9, right? So I have, let's see, I'm just going to do bit by bit. 5 times 9 over, all right, 2 to the 4th. So 2 times 2 is 4, times 2 is 8, times another 2 is 16. And then you go 1/2. And then do math. 5 times 9 is 45. And then 16 times 2, that's 32. And there, ladies and gentlemen, is my slope. More accurately, wait, was this F? What was this called? It was called Y. Okay. So Y prime of pi over 3 is 45 over 32. Okay, example 4, an object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by x of t equals cosine of t squared plus 1. Find the velocity of the object as a function of t. In order to find the velocity, you derive the position function. So I'm deriving. But of course, this position function is a chain rule. So that stuff there is going to be the inside function. So this is going to be cosine of u. So u is t squared plus 1. So du is 2t. All right. So velocity. Velocity function is the derivative. So derive cosine u. You get negative sine of u du. I already figured out what my du was. I know what my u is. I'm going to plug them in. So negative sine u is t squared plus 1. And then du is 2t. The only thing I would do here is move the 2t to the front. So negative 2t. And then sine t squared plus 1. And that's it. Okay, example 5. Find f prime of theta if f of theta equals sine cubed for theta. So, of course, chain rule, but this is the repeated use of the chain rule. That means there's a double chain rule. So I need to figure out what's all going on in here. The exponent is a very good indication that maybe that should be its own thing. So I'm going to rewrite this as sine 4 theta, and then the exponent on the outside, right? So this is going to be u cubed. All right, so u is sine 4 theta. Now that in itself is another chain rule. Eventually, you get used to the trig functions because the derivatives are really easy to do when it's a chain rule, and you won't even have to double up as much. But for now, I'm taking it slow. So this is now going to be sine of v. Okay, so I do need du. But before I can do that, I need v and dv. So v is 4 theta, and dv is going to be 4. So now I go back to du. All right, so du is the derivative of sine v. The derivative of sine v is cosine v, but because it's a chain rule, times dv. The derivative of the outside times the derivative of the inside. All right, now the v's and the u's, we should understand that they don't actually exist. So please, plug in what u and what v are supposed to be before going all crazy, right? So sine v is actually sine of 4 theta. And then the cosine v dv, that's actually, okay, so cosine of 4 theta times 4. Okay? But of course, I don't want you to leave it like that, so I'm just going to go ahead and rewrite it the proper way. 4 cosine 4 theta. Now, hopefully, at some point, you will pick up on the pattern. When I did u, right here, sine 4 theta, the derivative of that is just cosine, because the derivative of sine is cosine, 4 theta with a 4 in the front. The 4 comes from this 4 right here. Okay, you'll see the pattern that basically this number jumps to the front as well, because I still need both, and then the trig function gets derived. But I'm just writing it all out for right now. So I have all my pieces. Let me go ahead and do the derivative. So let me bring this down. Okay, so f prime of theta. Okay, so I'm deriving this function, the outer function. So it's 3u squared du. I know what my u and my du are, right? That was all that work I was doing earlier over there. So here's my u, and all of this is my du. So I could plug them in. So 3u, which is sine 4 theta, squared, times du, which is 4 cosine 4 theta. And basically that's it. The only thing I ask of you is to take the 3 and the 4 and plop them together because they're being multiplied. So there's 12. And then everything else is fine. Sine squared 4 theta, because that's where the squared is supposed to go. Cosine 4 theta. And that's that. Okay, example 6. Find the derivative of g of t equals tangent of 5 minus sine t, 2t, 2 times t. Okay, so hopefully it's obvious that all this stuff is the inside stuff. So this is going to be tangent of u. All right, let me take care of this then. So u is 5 minus sine 2t. Oi, that 2 makes it a chain rule. You could just be like, oh, that's okay, because when I derive that, the sine is just going to become cosine, and that 2 is going to come up to the front as well. It's a good technique or shortcut to learn or teach yourself, but I'm just going to take a step at a time here. So I'm going to go ahead and rewrite this as 5 minus sine of v. Okay, just for you guys. Okay, so I'm going to need du, but before I find du, I'm going to have to figure out what's going on with v. So v is just the 2t part, and then dv is going to be the derivative of that, which is 2. So du, let's see, I'm going to derive 5 minus sine v. So 5 goes away, and then I have negative sine v to derive left. So let's see, negative cosine of v dv. Okay, so let me actually plug in v and let me plug in dv, because those don't exist really, right? I need the real stuff. So negative cosine of v, let's see, where's v? 2t, right? Times dv, which is just 2. So once again, what happened? The 2 came up to the front, the sine became cosine. That's it. So negative 2 cosine 2t. Right, there's my derivative, or there are my pieces. Now I get to actually derive the function. So I'm going to derive this. So tangent u. Let me write g prime of t. All right, so the derivative of tangent is secant. Secant squared of u. But because this is a chain rule, times du. So I have secant squared. Let's see, what was u? In case we can't see, here is du. And, well, I don't want to use that one. I want to use this one because this one actually has the 2t plugged into it. All right, so there's my u and my du. Get back to what I was doing. So secant squared of u, which is 5 minus sine 2t, times du, which is a negative 2 cosine 2t. And then all I ask is that you bring coefficients, numbers, right? Multipliers, scalars, whatever you want to call them, to the front. In fact, I'm just going to go ahead and move all of that stuff in the back to the front because this stuff looks yucky. So negative 2 cosine 2t, and then times, or I don't need that. Negative 2 cosine 2t, and then secant squared, and that is 5 minus sine 2t, and that's that. All right, this one looks yucky. Find the derivative of f of x, but look at it. Parentheses and parentheses and a bunch of exponents. Okay, all of this is the inside function. So this is going to be u squared. So u is x squared plus 3 to the 5th plus x. And then du is going to be the derivative of that. But I'm going to tell you right now that this is also a chain rule because of this stuff in the parentheses. So I'm going to call that v. Okay, so this changes to v to the 5th plus x. Okay, so that means I need v, and I'm going to need dv. So v is x squared plus 3, so the derivative of that is 2x. All right, so back to du. I need to derive u. So u is v to the 5th, right? So that's 5v to the 4th. And then the plus x, when I derive just a lonely x, I get 1. Oh, but wait. When I did the whole 5v to the 4th, this is the chain rule, so I got to multiply by dv. Now I can do my plus 1. Okay, so that's the derivative of the outside times the derivative of the inside. And then when I derive the x, that's just a 1. Okay, now you're probably wondering, okay, should I have done that dv before or should I have done it after? The chain rule was only for the first half of the equation. It had nothing to do with x. So the dv does go next to the 5v to the 4th, and the 1 is not affected by the dv. Okay, just in case. Okay, no bueno how it is, because v's mean nothing in the real equation. So 5 times v is x squared plus 3 to the 4th power times dv, which is just 2x, plus 1. So this is what that should really look like. Okay, now I can go ahead and do the derivative of my u squared up there. So I'm going to derive this. So f prime of x is equal to 2u du. So now what I do is I plug in my u and I plug in my du. All right, I need my u and my v, or my du, sorry. And if you look, I did clean up the du a little bit. I multiplied the 5 and the 2, which I forgot to do beforehand. But no big deal. So I have my pieces. All I gotta do is plug them in. So 2 times u. U is just x squared plus 3 to the 5th plus x. And this is where you have to be careful. That 2 is multiplying u. U is all that stuff, all the green stuff, all of this, right? From here to here. So I need to make sure that all of that stuff is being multiplied by 2. So let me just use a bracket, and that'll be safe. All right, and then multiply by du. So what the heck? I'll use another bracket. 10x, x cubed plus 3 to the 4th plus 1. And as yucky as that equation is, I don't want to simplify it, so we're going to leave it like that. Please do your homework.